Since 1970, the Clean Air Act has provided the primary framework for protecting people and the environment from the harmful effects of air pollution. A key component of the Clean Air Act is a requirement that the U.S. Environmental Protection Agency, or EPA, significantly reduce daily, so-called routine emissions of the most potent air pollutants. These are the pollutants that are known or suspected to cause serious health problems, such as cancer or birth defects. The Clean Air Act refers to these pollutants as hazardous air pollutants, but they're also commonly known as toxic air pollutants, or simply air toxics.
Air toxics? Well, that's the stuff in the air that's bad for you.
Air toxics, those have something to do with big factories, don't they?
You hear a lot about ozone these days. I don't know that I've heard that much about air toxics. I guess maybe they're not that much of a problem.
Toxic air pollutants are those pollutants that are known or suspected to cause cancer or other serious health effects, or to cause negative environmental effects. The degree to which a toxic air pollutant affects a person's health depends on many factors, including the quantity of pollutant the person is exposed to, the duration and frequency of exposures, how dangerous the chemical is, and the person's state of health. The 1990 Clean Air Act amendments list 188 toxic air pollutants that EPA is required to control. The list of chemicals that are classified as toxic air pollutants includes benzene, which is found in gasoline, perchloroethylene, which comes from some dry cleaning facilities, and methylene chloride, which is used as a solvent and paint stripper by many industries. Dioxin, asbestos, toluene, and metals such as cadmium, mercury, chromium, and lead compounds are also classified as toxic air pollutants.
I know that the horrible forest fires we've had have caused a lot of air pollution.
Air toxics are a byproduct of major manufacturing processes, aren't they?
Scientists estimate that millions of tons of toxic pollutants are released into the air each year. Of these, most come from man-made sources, including both mobile sources, such as cars, buses, and trucks, and stationary sources, such as factories, refineries, and power plants. While some air toxics do come from natural sources, such as forest fires, the EPA Air Toxics Program concerns itself with normal, everyday emissions from stationary sources. These emissions make up almost 1/2 of all man-made toxic air emissions. These stationary sources come in two types: major sources and area sources. Major sources are sources that emit either 10 tons per year of any listed toxic air pollutant or 25 tons per year of a mixture of air toxics. Examples of these sources include chemical plants, steel mills, oil refineries, and hazardous waste incinerators. Major sources can produce negative health effects on populations located downwind from them. This is one of the key public health concerns related to these sources. Area sources consist of smaller sources emitting either less than 10 tons of a single air toxic or less than 25 tons of a mixture of air toxics. Area sources include neighborhood dry cleaners and gasoline stations. While these sources don't produce a lot of air toxics, relatively speaking, a large group of them located near each other can produce enough emissions to be a problem, particularly in a heavily populated area. EPA has identified 175 source categories and determined whether each is to be considered a major source or an area source. The 1990 Clean Air Act amendments direct EPA to set standards requiring that all major sources and some area sources that are of particular concern significantly reduce their air toxics emissions.
They go into plants and animals and make them sick.
Air toxins really don't go anywhere.
Once they are released, toxic air pollutants can be carried by the wind, away from their sources to other locations. Factors such as weather, the terrain, and the chemical and physical properties of a pollutant determine how far it is carried or transported. In addition, the properties of the pollutant will also determine its concentration as it moves away from the source, the kinds of changes it undergoes, and whether it will degrade, remain airborne, or deposit on land or water. Some pollutants remain airborne and cause air pollution problems far from the pollution source. Other pollutants released into the air can be deposited to land and water through snow or rain, or by just settling directly out of the air. Some of these toxic air pollutants are of particular concern because they are persistent or remain in the environment a long time. These pollutants do not degrade quickly. Often, a cycle begins when a pollutant is deposited on the ground, then evaporates back into the atmosphere, is transported, and then deposited back on the ground again. In this way, pollutants can be carried very long distances. For example, toxic pesticides used primarily in the southern United States have been found as far away as Antarctica.
I know that I stopped eating a lot of the fish that I catch because of concerns about pollutant levels in the stream around my house.
It's a real problem when just breathing exposes you to dangerous chemicals. It's not like you can just stop breathing.
People are exposed to toxic air pollutants in many ways, such as by breathing contaminated air, or eating contaminated food products, such as meat, milk, or eggs from animals that have eaten contaminated plants. People are also exposed by drinking contaminated water and eating or touching contaminated soil. Once toxic air pollutants enter the body, some persistent ones, such as mercury, accumulate in body tissues. To make matters worse, through a phenomenon known as bioaccumulation, predators accumulate even greater levels than their prey. This means that people and other animals who are at the top of the food chain can be exposed to much higher concentrations than those found in the water or soil. This process is particularly dangerous where fish are concerned. Nationwide, fish advisories have been issued for over 52,000 lakes and over 238,000 miles of rivers. Many of these water bodies were thought to be relatively pristine. However, EPA is now discovering that deposition from the air may be a major source of pollution in these water bodies. Right now, many states have advisories relating to fish which are contaminated with mercury.
Things like mercury that build up in fish can cause major birth defects.
People always focus on the impact that these chemicals have on humans, but they also impact plants and animals.
DDT is a good example. The government actually had to ban the use of it because it had such a negative impact on the environment.
Toxic pollutants affect both human health and the health of the environment. When people are exposed to toxic air pollutants at sufficient concentrations and for sufficient durations, their chances of getting cancer or experiencing other serious health effects may increase. Depending on which pollutant a person is exposed to, these health effects can include damage to the immune system, as well as neurological, reproductive, developmental, and respiratory problems. In addition, a growing amount of evidence suggests that some air toxics may disturb hormonal systems. This can cause reduced male fertility, birth defects, and breast cancer. As mentioned earlier, air toxics don't just affect the health of people, they affect the health of the environment too. Like humans, animals can experience health problems if exposed to sufficient concentrations of air toxics over time. Toxic pollutants that mimic hormones, such as DDT, dioxins, and mercury, have been associated with decreased animal fertility, decreased hatching success, damaged reproductive organs, and altered immune systems.
Congress created EPA to protect public health and the environment. One of EPA's most important tasks is to regulate air toxics. EPA places limits on factories and other sources to reduce air toxics.
Before 1990, the Clean Air Act directed EPA to regulate toxic air emissions based on the risks each pollutant posed to human health. Specifically, the EPA had to identify all pollutants that cause serious and irreversible illness or death, and develop standards to reduce emissions of these pollutants to levels that provided an ample margin of safety for the public. While attempting to control air toxics in this manner, EPA became involved in many debates over which pollutants to regulate and how strictly to regulate them. In addition, there was the question of how safe is safe. During this time, EPA was still developing methods to determine the degree of risk involved with air toxics. While these assessment studies led to valuable information, regulation proved to be more difficult. In 20 years, EPA regulated only 7 pollutants, cutting annual air toxics production by an estimated 125,000 tons. While this was an excellent result, it wasn't nearly enough. Realizing the limitations of a chemical-by-chemical analysis based solely on risk, Congress adopted a new strategy in 1990 when the Clean Air Act was amended. Congress revised the Clean Air Act to require a more practical approach to reducing emissions of toxic air pollutants. This approach has 2 components. In the first phase, EPA develops regulations requiring sources to meet specific emissions limits. These limits are based on emissions levels already being achieved by many similar sources in the country. These regulations are known as MACT standards, standing for Maximum Achievable Control Technology. MACT standards are based on the emission levels achieved by the best performing facilities. In other words, if some facilities have managed a 20% reduction, then the MACT standard will be a 20% reduction. This means that all similar facilities will be held to the same standards. This keeps some companies from profiting by using cheaper, less effective control technologies than their competitors. Wherever possible, EPA writes the MACT standards as an emissions limit. That is, either as a % reduction in emissions or as a concentration limit that regulated sources must achieve. This way, regulated facilities have the flexibility to determine for themselves the most effective way to comply with the standard. After the MACT standards are developed, in the second phase of the process, EPA assesses how well these standards are reducing health and environmental risks. If necessary, EPA may then require additional controls or reductions. When fully implemented, all of these standards will reduce air toxics emissions by about 1.5 million tons per year, almost 15 times the reductions achieved prior to 1990. As an added bonus, some of these air toxics rules have the added benefit of reducing other air pollutants. To date, EPA has primarily focused its efforts on MACT emission standards. Over the next few years, EPA will continue to develop standards for all of the remaining source categories and reduce air toxics emissions even further. EPA anticipates that its technology-based approach will continue to prove successful at reducing air toxics. So, between these new standards and other continuing efforts, the Environmental Protection Agency is committed to reducing air toxics emissions and making our country a cleaner, safer place to live, work, and play.